to talk to you about NASA technologies for your Mars-related project. Okay, I've been a long-term Mars Society member myself, commander of MDRS Mission 61. I've also been around the Johnson Space Center with various contractors since '87. I've been in Shuttle, NASA Mir, Space Station, Constellation, with our Lunar Habitat Mockups program. And since 2009, I've been with the Technology Transfer Office, reviewing all the brand new inventions and technologies that get reported into our office.
And I'm fairly new to the space world, so to speak. I'm a graduate student in the master's program of space studies at the University of North Dakota. And I'm currently here working on a 10-week internship in the Technology Transfer Office. So actually, tomorrow is my last day. I get to head out to New Jersey and visit family for a bit, and then back to North Dakota, where the weather is much nicer this time of year. I have done some analog work at the University of North Dakota. The LNAH is our Lunar Mars Analog Habitat. It took about 4 years to build it. And we just did back in last October, November, our first 10-day analog test. So it's kind of similar to the MDRS, just that it's in North Dakota, not Utah. So it's a little bit less of a Mars-like environment where it's put. But we plan to do similar type testing in the near future. So we're doing our next test. It'll be a 30-day test this coming October. So that's where I'm coming from. Chip.
All right, now let's get started here. Our purpose today is to talk about, and tell you guys about this really huge portfolio of NASA technologies that's been developed, it's been processed all throughout the line, and a whole bunch of it has gone through all the hoops, and it is available to the general public. It is now public domain. It is available to you. Just hardly anybody knows about it or how to access it. And so we're here to tell you about it and how it can be, how you can make use of it possibly for whatever it is that you guys do. All right. Right now, first we'll tell you about the Technology Transfer Office. I mean, these are the official words that we put out about it. Yada, yada, yada. Tech transfer basically is about giving back. American taxpayers, all of us have paid for all these great technologies, all this great work that NASA has done. What tech transfer attempts to do then is to take that, try to find ways to pump that back into the American public and to raise the standard of living, raise our standard of living, make new products that haven't existed before, and just improve life for all of us and get a little return back on our tax money. The technologies that we get in, they can be all sorts of things. It can be new materials, sometimes it's robotics, sometimes it's software. It doesn't even have to be brand new inventions. I mean, sometimes, even if it's just something they bought off the shelf and it's an improvement on something, well, that is a technology disclosure they have to turn in. And so that is part of our portfolio, part of our database that's available as well. So the first step that happens is when we get these inventions, they have to document these in what we call as a new technology report, or it's a disclosure, what I like to call it. So they have to fill in this disclosure, and they have to disclose the invention. So all the information is in there. Stick that into that report that gets turned in. And we take that report and we put it through our process, and we work with the Patent Council at JSC, because the first thing we got to do is we got to sort out the intellectual property that's there. You know, what belongs to the company, what belongs to the individuals, what belongs to NASA. And so we're working with them on it, and as the result of it, a whole bunch of them, you know, they eventually get to a point where they're free and clear in public domain. Although some of them may go different routes, we may end up deciding to patent it ourselves, or the company may decide to patent it. But those are about, 1% is what NASA decides to patent. About 3 to 5% is what the companies go with. So the vast majority of these, they sail through that process without everybody in fact signs off saying, I do not want to patent this. And so then that's what makes it okay to go to the general public for public domain. So then we can put it into NASA publications, and get that on there. So an example of those So an example of that, we put it into like our Tech Briefs, NASA Tech Briefs magazine, which comes out every month. And we got a whole bunch of these, by the way, back there for you to take. And I encourage you to take them because I am not going to take them back.
Okay.
There. We have Spin-Offs magazine, which is big with Congress. Our software catalog is one of our newest publications. It lists all the software that is available for people to select. And next chart. There we go. Now, how do you guys get access to this? Well, you come over to Tech Transfer and you knock on our front door. We have the front door. And you can come to us with your inquiries, and we have our email address, jsc-techtran@mail.nasa.gov. Easy to remember, top of your head. Look at that phone number, 281-483-2803. Easy, easy. But yeah, through these two methods though, we can search our MTTS system, which is our tool, which is our database. It's got all of these technologies in them, and it is a searchable database that we know how to operate. We can operate it on your behalf with whatever kind of topic that you're looking at, whatever time frame. I want to go 10 years back, I want to go 15 years back, I want to go 8 months back. And we can see what the freshest stuff is or what comes from particular time frames. And there's different ways we conduct that search for you and let you know what kind of technologies we have, especially the ones that are free and clear and already in the public domain and are available to you without you even having to sign a form or a non-disclosure agreement or anything. There's a whole bunch of those. In fact, we conducted a search like this as an example to bring here for our talk today. And to tell you more about that and the results of it, I'm turning it over to Tim.
So as Chip mentioned, we use the MTTS system to be able to search for these technologies. And if you come in and you give us a request, we can find specific things that you're looking for. So we started with just a general search for the two keywords, Mars and planet. Okay, so we could get things, in this case, it'll bring up technologies in which the innovators have mentioned Mars or planetary research in their abstracts. Okay, so this is just the ones where they've talked about it in their disclosure. Okay, so there's a ton more, there's thousands more that would be applicable to Mars research that didn't come up in this particular search. So by emailing us or calling us, coming through the front door, you can tell us exactly what you're looking for, or give us a general idea of what you're looking for. And we'll be able to, search for it here. But Chip has been doing this job for 5 years. He has most of them memorized. He wouldn't even need to do a search. He'd know, he'd already have a few examples of something you might be interested in. All right, so we can look it up fairly quickly. The other thing is this MTTS system is open to all the NASA centers, not just JSC here, but we can search the disclosures for all of the NASA centers and get data on them to see if they are available to be released and if they're useful to you in any way. So in the general search we did here, the abstracts, Mars or planet, about a little less than 2,500 came up when we searched in all of the NASA centers. Okay, so we whittled that down a little bit. Just the ones from JSC that mentioned Mars or planet came out to 105. Okay, the ones that ended up in the Tech Briefs magazine was about 41, and that's pretty representative of at least what Chip has told me. About 40% of the disclosures that come through our office end up in the Tech Briefs magazine. So here, just with the Mars and planet, about 40% ended up in there. So it's pretty representative of the entire field. And 25 of those that ended up, well, 25 of those 105 are available for release. They're not being patented by us or by the associated innovators. So out of those 25, I picked a few notable ones to talk about now that you may find interesting. This one, okay, it's a dust distributor. By the way, these numbers here, up here, okay, these are our code numbers. So MSC, what does the M stand for, Chip? Manned Space Flight Center. Okay, so it's, yeah, the MSC is the code for Johnson Space Center, but as Chip said, it's Manned Space Flight Center. Spacecraft Center, okay. Which was the old term for the JSC. So anyway, these are our code numbers. We'll do a search and be able to find the code numbers. But this particular example, it's a dust distributor capable of distributing fine dust in a uniform fashion on the surface. Each layer is uniform across in this case they use little discs to test it, but each layer of dust is uniform across the disc. And each disc has a uniform layer of dust through this. So if you're doing dust study research, here they used a Mars simulant on the effect of the dust piling up, or if you want a steady layer a uniform layer of dust for whatever reason. One thing that they mentioned in their disclosure is that you can, once you get the uniform layer, you can sinter the dust and have a protective layer on something that you may need a protective layer on. So there's a bunch of uses for this, and actually the key technology to make this was an upside down coffee grinder. So let's see. And one of the other things that they mentioned is really key to this is that unlike other dust distributors, you don't have to take the disk out of the unit to move it to wherever you're doing your experiment. You can move the entire thing. It's fairly portable. So you can move the tray with the discs on it without disturbing the dust by creating a breeze or whatever. It's enclosed in the way they've done this. Okay, another one, we got the sheet membrane spacesuit water membrane evaporator, or SWIMMY. Okay, and then the hollow fiber version of SWIMMY, HO-FI SWIMMY. In this case, it's for portable life support. And in here I showed, we got two pictures of the old style portable life support system, the Apollo style, in which they use a sublimator for the heat transfer with the space environment. Well, that's great in a vacuum, but in low pressure, in a pressured system, say the atmosphere on Mars, the sublimator doesn't work so well. So instead they came up with an evaporator, which fits into this little cylinder. I don't recall how big the cylinder actually is. Most of this was built from commercial off-the-shelf materials. The hollow fiber membrane is used, or has been used, as a sort of breathing filter, I believe. I don't have my notes in front of me, but I think it was used as some sort of breathing filter previously, and they've used it and they've put it into this evaporator system. So in the regular SWIMMY, it's actually kind of similar to the sublimator. They use Teflon sheets, and the liquid gets into the pores on the Teflon sheets, and then it evaporates from the pores, and that's where the heat exchange happens. With the hollow fiber one, the evaporation happens from within the hollow fibers. The fluid gets into the hollow fibers and evaporates and exchanges the heat in that manner. This one's pretty cool, and we like it because they gave us an actual sample to play with. The touch temperature coding for off-the-shelf electrical equipment used on spacecraft. So In this case, they were talking about in spacecraft, when you use commercial off-the-shelf electric equipment that was built for terrestrial uses, because there's limited heat exchange in microgravity, there's no buoyancy, so you don't get convection. The electrical equipment will tend to get very warm, and when you touch it, it's going to be, it could be above the pain threshold, and you need to insulate it some way so that the astronauts can work with it. So in this case, they came up with an insulating layer. So you got on both the top and bottom of this layer is a thin layer, 0.4 centimeters, I think it was, of aluminum. And then between it, you got this square wave pattern of stainless steel. And what that does is it insulates it so that you can work with the equipment without burning your hands, without feeling, without enough heat transfer to bring you above the pain threshold. But it still allows the instrument to exchange heat with the environment. So, and that's from the square wave pattern stainless steel in there. It allows enough insulation where you're touching it. It provides resistance to the heat transfer where you're touching it. But in other regions of the layer, it's able to still transfer heat to the environment. And this one I think was this was Don Pettit, right? This one was Don Pettit? Okay. All right, so this one, the high temperature sealant compound for use in the vacuum and temperatures found in Earth orbit was developed by an astronaut, Don Pettit, and it was developed for the shuttle program just after Columbia? Yeah.
Tower.
What was that?
Part of the tower.
Yeah, part of the tile repair initiative after Columbia. So basically, it's a putty, right? And you can stick it in. You can plug leaks or areas. Basically, it's a putty. You're spackling the tiles of the shuttle is the idea here. And if you heat it, it becomes solid. So it starts out as a putty. And when you heat it, here they did a test with a heat source of some sort. I don't remember. Again, I don't have my notes with me today. But they heated it, and it turned solid. And once it's solid, it's a more resilient, permanent solution here. So the thing is, once you come in through the atmosphere, it gets heated, and now it's even stronger than it was when you plugged the hole in space. So instead of getting worse, it gets better. Unfortunately, for whatever reason, it turned out to be incompatible with the actual tiles that they use on the shuttle. So it wasn't actually useful for the shuttle, but you know, other things in space, it can plug the holes, it can be useful for those. So we keep it as something viable for future issues and missions. And then there's surface navigation using particle swarm optimization. So, you know, it's summer. You see the swarms of mosquitoes outside all the time. Not around here so much, but you know, all over the world there's swarms of locusts every couple of years. You can see those. And the neat thing about these insects is that, you know, as dense as the swarm gets, no matter how close and how fast they're flying, they never collide with each other. And that's kind of the core technology in this one. It was borrowed from the insects in a way. But it's a way to navigate through a complex system of obstacles, say craters on the moon or on an asteroid. It can, if with an accurate map of the layout, it's an algorithm that can determine the most efficient path to navigate from a start point to an end point. So they actually guarantee that it works, provided that the map is sufficiently accurate and sufficiently precise as well. So this is one of my favorites because I my other love besides space science is entomology. So the fact that it comes from insects is really neat to me. It's inspired by insects. But you know, for any robotic applications, this is great. Robotic rovers, even on Earth, you got the robots that go in and defuse bombs, the robots that go in looking for mines. So anything that needs to navigate around obstacles, whether it's on Earth, in space, on Mars, this is applicable there.
Would it be useful in aircraft landing patterns?
I don't know. I think this was designed mainly as a two-dimensional system when they initially did it. It could probably be expanded to 3 dimensions in that case.
What is that?
So again, our main point here is to be able to transfer this technology to you. Okay, so if you're doing a research project of any sort, right? These 5 technologies we just talked about, the other 25 that we have at JSC, and the other hundreds that we have at all of the NASA centers, okay, are free and clear, available for your use. You just need to call one of the front doors for one of the NASA centers. Call us because we're cool. Just call us and tell us what you're looking for. We can give you the information. Most of us are technology experts who will be able to determine what it is you need and get that to you. As Chip mentioned, we have some of our Tech Brief magazines on the table in the back. Please take them. We also have some business cards with the email and the phone number there that will also help you. We want to really bash this into your brains that you can get a hold of us and ask us for these things, because that's the whole point of technology transfer to begin with. And also we have some stickers back there these stickers back there from the 33, Expedition 33 of the ISS. So feel free to take these as well. And if we run out, we do have a few more.
So do I just call you up and will you send it to my house, or how does that work? Or do I have to actually go up to the center and purchase it there?
How it work is, yeah, you can give us a call or send us the email, and the person who manages the front door for our office, he takes them in. He might send you a form, a standard form, where you can fill out a little more information about exactly what you're looking for if he feels like he needs you to. Sometimes he does that, sometimes he doesn't. But sometimes he just forwards the email to the right person that is best situated to answer it. And if it's somebody who's inquiring about what kind of technologies do you have for this particular area, he routes a lot of those over to me personally, because that's what I do, is I look at these things all the time. So the request might come directly to me, and then I would either call you back, or I might, if you've got enough detail in your email, I'll just respond directly to your email.
So this isn't like it directly, like you guys have like a storage place where you sort of buy it. You have to sort of go through a process before I exactly.
Yeah, I mean, it takes a trained person to work MTTS, but that's what that's what our office is. We're trained at MTTS, and if you come and say, what kind of technologies you got in this particular area or that particular area,
well, because I saw like specific.
then we can respond to that.
I saw like specific products, and if I know what I specifically want, do I still have to go through that whole process, or can you guys know what I want, and then you can just send it to me, and I just send in a check or something? Or?
Yeah, no check or anything. It's anything that's public domain, we would send it. Anything the public is allowed to have.
Oh, so it's like if I'm doing like a project or something, you guys want
We
to
do
contribute.
a lot of school projects, yes.
Okay.
We do.
That's great.
What if I'm just curious and I was like, hey, I don't have any like specific project in mind, and I say, hey, I want to know as much as I can about X. Is that something I can
About robotics,
do? Yes.
let's say. So,
Or
yes.
a space atmosphere suit or something like that, space suits.
Yeah, then I might like actually give you a call and go, you know, hello, it's a big area, you know, or any particular thing that is driving behind it, a paper, a book you read, something you saw in Tech Briefs magazine, what's that code number in the corner, you know. But if I don't have that, I mean, in general, I would respond back to you going, okay, the area of robotics is this NASA site and that NASA site. There's a couple of these things that we recently patented, and they're, you know, patents are publicly available information. I give you the website right there. And then I might give you one of the cool technologies that I'm always trying to push, like that goop, that Don Pettit goop. I mean, that's good stuff. I mean, it didn't work with tile, but it could be applied to vacuum and not bubble or anything. I mean, it's good stuff. Every glue works with some things and doesn't work with other things. So right now, nobody's using that goop for anything right now, but you know, I hope somebody starts using it for something. It's right there and for anybody to use, first come. So did that answer your question?
Close enough.
Okay.
How
Yes.
does the Space Act agreement works into the relationship with the technology?
A Space Act agreement is kind of a little formal kind of thing when they want to do something, actually do something with JSC. The Space Act agreement is the quickest, most effective way for that to happen. And you might put in your initial request through the front door and see if that can be answered in a less formal, very quick, you know, more quick kind of way. But if Space Act agreement turns out to be the right place, the Tech Transfer Office is the place where those Space Act agreements are done. And those, you know, one of those guys that does Space Act agreements, we have lunch with him every Wednesday. So we would get him in contact when that was the right thing to do. We'd make that connection because that's in our office.
So it just depends upon the application and the partnership, in the sense that tech transfer, you will give away the technology to whoever the individual.
Yes, but you know what?
But the Space Act agreement, you have then a legal situation here with an entity, whatever that is, personal or company.
That's right.
Okay.
So the front door is a good place to come in to go, you know, I think I'd like to get into a Space Act agreement because I think I really want a partnership. Well, then we're going to route it to a different place. We also get them, they come in, they say, I saw this technology on the patent site, I want to license it. Well, they send that to the front door, and I go send that over to our licensing manager at JSC so that they can pursue that. So, you know, so we're just telling you one little thing that the front door does. But yes, but Space Act agreements, partnerships, licensing, they all can be initiated and inquired about through this front door as well.
What was that link to the search page again?
To our webpage?
No, I'm on the web page, I just didn't find the search, where you're searching for the technologies.
Oh, you do not have access to the
Oh, okay.
MTTS, that's only us.
Okay.
That's why we have the front door, because the MTTS system has the information on all of our technologies that come through NASA.
Okay.
Including the ones that are still underway of being considered, like where are we at with the
So some stuff is for
That's our
release and
management
some
tool.
stuff is not.
Right.
It's our management tool, and you got to train, really, a trained person is required on using it, so it's not ready for public use. But, you know,
That's
we
what
can
y'all
use it
look
for your behalf.
Yeah, exactly. Half the job is releasing it to the public, the
Okay.
other half is protecting the intellectual property.
Sure.
Thank you. We
We've time for
might
one
have
more
time for one
question.
more if there is. Yeah?
You said at one point the phrase "no charge" or something similar. Is it the search that's no charge, and then depending on what you find, there may or may not be one?
Yes, yes.
So it's all
Searches
free.
don't charge, you pay taxes, so.
Yeah, okay.
Whatever. Our licenses, you know, when we license a patented technology, there's a fee for that, but actually those are bargains. They're not in it to make money. But yes, this whole searching and getting responses to your email, calling us, getting responses to your calls,
So
yes,
then-
no charges.
So then if somebody found through the search process something they wanted,
Yes.
then you talk about licensing
If,
or whatever.
if it's public domain, I'm just gonna put it in an email and send it to you.
Oh, okay.
We can
So
tell you all
the
that we
licensing
know.
would apply if it's something that is patented.
If it's, yeah, if it's patented by JC, yeah, then licensing might get involved.
We can tell you all the details we know,
Yeah.
but we can't guarantee that if you go and talk to the innovator, they won't try to sell us.
Yeah.
Okay, that's a great group. Grab the stuff. Please grab the stuff.